Okay, this is the video guiding you through probability examples. So let's start off with one. We're not going to do Venn diagrams too much in the course, but the book does talk about it, and it's an alternate way of understanding what we've been doing so far, and it helps out sometimes with pictures. So we got 100 students. 30 are taking math right here, 30, and we'll put M for math, right? And then 20 are taking music, and 10 are taking both. Now, if I drew this separately from music, the problem is there's 10 who are taking both. So I can't draw these two separate. When you have two circles that are separate, that corresponds to the idea that we've been talking about before, mutually exclusive or disjoint. There's two separate things. In this case, there's overlap between them, intersection. Why? Because there's 20 taking music, and then 10 who are taking both of these things. So the question here is, if a student is selected at random, what is the probability that he or she is taking math or music or both? So probability of math or music or both. Okay? Well, how do I do that? I first have to count this up. There's 30 math students plus 20 music students. But if I count that up, 30 and 20, 50, I've counted one group here, and then I've counted another group there. I've counted this inner area right there twice. So I have to subtract off 10 because there's 10 who are taking both. I've included the 10 in that first count for 30 who are taking math, and then I've counted again those 10 because they're also taking music in the 20. I have to subtract off 10 to get the proper count. That gives me what? 50 minus 10, 40. So the probability is going to be that over 100. So 40 over 100. That's the probability that if a student is selected at random, you're taking math or music or both. This area outside here is the remaining students who are taking neither math nor music, right? 100 students outside, assuming this is a complete diagram. Okay, skip the second part. Let's go on to 2 now. So determine the probability of each of the following events, indicate how you work it out. Remember, the work is everything, showing me the work. An even number appears in the toss of a fair die. So you got a fair die, an even number. So what's the probability of getting what? What are your events? Always inside probability are events, never numbers, never ever numbers. You put numbers there, I'm not going to be able to give you proper credit. So what are the events? Well, in even number, what are the even numbers you can get? You can get T for 2, or F for 4, or S for 6, right? I want to then do this. Every time I see or, I want to, but I can't necessarily add them up. I want to do this. Probability of T plus the probability of F plus the probability of S. Anytime I see or again, I want to add. But in order to add, you have to apply mutually exclusive or disjoint. Well, the idea here is, if I get a 2, can I at the same time get a 4? No. Can I at the same time get a 6? No. So these are separated out, so it does indeed fit the definition of disjoint. I can add 2 up, so that gives me the probability of 2 is 1 over 6 plus probability of 4. There's only one 4, 1 over 6 plus the probability of 6, 1 over 6. And indeed, it adds up to 3 6, which is 1/2. It makes sense because there's half even, half odds. It should be 1/2, right? Okay. Number 2. Part 2 of number 2. A king appears in the drawing of a single card from a standard deck of 52 playing cards. Well, how many kings are there? We've already done this, but let's do it real quick again. We did this in the previous exercise in the book. Probability of a king from the standard deck equals, well, how many kings are there? There are 4 of each suit, so 4 out of 52, right? All right, 3 is a little trickier. So 3, let's separate that off right here. 3 says, what's the chances of getting at least one tail appearing in the toss of 3 fair coins? That's actually hard to do because you got to count them up. I mean, if you think about it, at least one tail includes getting one tail, 2 heads, or a head and tail and a head, or a head, a tail, and so on. At least one, that includes also 2. So I got to get 2 tails and a head. Oh man, that's too much. You got to count them up. So this is harder to do. I'm going to apply something called the complement here, which helps out. The complement is taking a look at the opposite side. So what's the opposite of at least one tail? The opposite of at least one is 0 tails, right? Again, think about it. The opposite of at least one tail is less than one tail, which is no tails. What does no tails mean? All heads. What are the chances of getting all heads in 3 tosses of coin? To get the probability of heads, heads, heads right there, that equals, well, think about it. Heads and heads and heads. There's an and in there. In 3 tosses, and I want to multiply times probability of H times the probability of H. I can because these are independent events. It's a fair coin, so each toss has no memory of the previous ones. So this will be 1/2 times 1/2 times 1/2, which is 1. 2 times 2 is 4 times 2 is 8, 1/8. The complement now, since I did the opposite, I said the probability of getting no tails, right, which is 3 heads. The probability of that is 1/8. So now I have to flip it around, the opposite. So I take 1 minus 1/8, and that gives me the remaining, and that equals 7/8. So that means the chances of getting at least 1 tail is the opposite of getting no tails. So that's 1 minus 1/8, that equals 7/8. So that gives you your other way to do it. If you don't believe it, let's do a real quick counting argument. So I could get either heads, tails, tails. Let's do at least 1 tails, right? So tails, heads, 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 tails, heads, 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 tails. That's 1. Now for 2, I could get tails, tails, heads, tails, heads, tails, 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 heads, right? And then the last one, when I get 3, is only one combination there. 1, 2, 3, 4, 5, 6, 7. 7 out of 8 possible total tosses, because it's 2 times 2 times 2, gives me 7/8. But the easier way to do it, the slicker way to do it, is the one I just had. Take the complement, right? You take the complement and you get 1 minus 1/8 equals 7/8. That's the reverse. But the complement idea will be important later on. I'm just indicating to you now how it works. All right, for 3, real quickly, you got 2 Russians, 3 Americans, and they're playing a chess tournament, right? Those from the same country have an equal probability of winning, but each Russian is twice as likely to win as any American. So I've got here O for Oleg, S, they're Russian, they're twice as likely to win, so you weight them twice as much. So let's say 2 and 2. The Americans, A, B, C, just get 1. The Russians are twice as likely to win as Americans. I didn't have to choose 2 here. If I chose 2 here for the Americans, I'd have to choose 4 there for the Russians. So I can weight it like that. Okay? And now they're asking, what's the probability that an American, not just A for Albert, but American, whatever, I can't spell, American wins, right? That equals probability of, there are 3 Americans, A or B or C, right? And can I add these up? The answer is yes, because these are disjoint. If one of them wins, the other one doesn't win, right? So whenever one occurs, the other one can't occur. There's only one winner. That equals the probability of A plus the probability of B plus the probability of C. Well, how do I figure that out? What's your total weight? You can think of these as weights. This is 1 gram, 1 gram, 1 gram, and this is twice as likely, 2 grams, 2 grams. So add up the total weights. 2, 4, 5, 6, 7. So it's out of 7. And then the chances that an American wins is 1 plus 1 plus 1. So it's 3. 3 out of 7. Okay? If that makes sense, great. Let's move on now to 4. 4 says a coin has been weighted so that heads is twice as likely to occur as tails. Find each of these probabilities. So the idea is, again, you can think of the same way. If a coin has been weighted, so here's heads, there's tails. Tails is 1 gram. It's been weighted so that heads is twice as likely, so let's call that 2. So it has a factor of 2. You can think this is weight, right? If the heads is twice as likely to come up, then this is 1 gram and that's 2 grams, right? So the total space of possibilities is 1 plus 2, 3, right? What's the probability then of getting H? Well, H is 2, and it's out of 3. What's the probability of tails? Well, it's the opposite of that, the complement. If that's 2/3, the remaining portion has to be, because there's only heads or tails, right? 1 out of 3, and that fits indeed here. There's 1, and then there's 3, so 1 out of 3. Okay, that's it for the practice. Be sure to continue with the reading and pay special attention to the exercises. Remember, the course is about acquiring skills, so Even though it seems like we're going a little bit quickly, or some of this might be going over your head, the practice is key. When the thing needs to start solidifying, I'll let you know, but we're going to make repeated passes at all these concepts. So the key is you got to keep pace with the work. You can't delay. Logic is not like one of those courses where you can make up stuff at the last minute. You got to keep a pace. You got to put in the effort. Okay, folks, see you next time.